Good afternoon to everyone. Nice meeting you all here today again. Now, in continuation with the earlier topic, what we dealt with was the construction of a boiler in unit number 1 we dealt with. And the second topic, second unit was with regards to mountings on the boiler. That is various types of mountings like your main steam stop valve, auxiliary steam stop valve, feed check valves, then your boiler gauge glass, your boiler safety valves, your boiler air vent, and so on. Scum blow down, bottom blow down, and then the ship side blow down valves we discussed on. Now, today we are going to start a new unit which deals with the feed water. The water which we are going to just put it in the boiler, how it should be, and so on. Now here, yes, the Marine Boilers, Steam Engineering, unit number 3, myself, BHOOPATHY BHASKARAN, from Marine Engineering Department, I'll be taking this topic. Now on feed water system, how this feed water should be, what quality it should possess, is the core for the complete performance of this boiler. You know, a boiler we have constructed, we're going to put in water and we're going to generate steam out of it and take that steam and use it for various purposes. Like in a motor ship, we will be using it for heating of fuel oil, service tanks, settling tanks, in the purifier, to raise the temperature, and in your bunker tanks and lube oil settling tanks, service tanks, we'll be settling tank and so on, we'll be using it. And then to maintain main engine viscosity, fuel oil viscosity, we will be using the steam to heat that oil. Now, when you receive the bunkers, fuel oil bunkers, it will be around 990 CST at 50 degrees centigrade. Now, you cannot use that 990 CST of viscous oil straight into your fuel injectors. So you have to heat it up and bring down the viscosity between 7 to 12 CST, and the temperature would be approximately around 145 degrees centigrade. So you have to do the heating and you use this steam to heat there in motor ship. In a steam ship, the same way, the fuel has to be heated up and before it is sent into the burner for your atomization and then the burning to take place in the furnace area. Now, feed water system. Now here is a simple diagram. I have not mentioned what is called an auxiliary boiler and so on. Now I would like to ask you all to participate in this event and tell me which could be the auxiliary boiler, and various labelings I have just given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to 18. Yeah, let us share with each other what could be which equipment. Like marine auxiliary boiler, this could be the auxiliary boiler, no doubt. Okay. Then circulating pump. Now, how can we identify? Where can we identify the circulating pump in this? Now, we have seen circulating pump means something to circulate. Now, why do we need a circulating pump? We have read about this exhaust boiler, number 3, that exhaust gas economizer, where the exhaust from the main engine is passing through this fin arrangement, which is called as an exhaust boiler. Now, here we are extracting heat out of this exhaust gas, from the main engine, the exhaust gas, which is at a very high temperature around 450 degrees centigrade. We don't want that 450 to just go away simply like that. So we remove the heat from there, and the heat exchange takes place, and the uptake temperature would be around approximately 180 to 190 degrees centigrade. Now for that, you circulate the water using a circulating pump. This is a circulating pump. The water is taken from the boiler and it circulates in the coil systems or the fin arrangement and back as a steam form here into the boiler. It is dumped back again. Okay. Now the fourth one, main steam stop valve. This is called a main steam stop valve. From here, as the steam is generated, it passes on. It goes to the headers. It goes to the steam distribution header. This part is called a steam distribution header. Now in the steam distribution header, it goes to various places like whistle, steam and so on. But here one is shown where it goes to the settling tank. It goes to the fuel oil settling tank, number 6. This is the fuel oil settling tank. It goes and heats up this oil in the settling tank. Now, why should we heat the settling tank? Now, the fuel bunkers what we received was 990 CST at 50 degrees centigrade. Now, this oil, using a transfer pump, you are transferring it to the settling tank first. There, you are giving time for the oil to settle. Now, the more higher the temperature, the faster the separation will be. Like your silica, your ash contents will get separated out here, and you can, and this oil is sent to the purifier, and then it's purified. But then you have to heat it up. From 50 degrees, you have to bring it to around 90 degrees to 95 degrees centigrade here in the settling tank. That is why you have a steam heating coil. After heating it up, it gets condensed. Heat exchange takes place, and then it returns back to another header, number 7. It's called as condensate return. All the returns from various points, from here, after doing its heating job, it's returning back. Now from here, after going for your AC system, air conditioning system, or to another, service tank or something, it goes in and then comes back again here. And from here also, it can travel and join up here. Okay, after passing through your freshwater generator and so on, steam heating system and so on, it can come to the condensate return. From the condensate return, it goes to the surface condenser. This one is called as a surface condenser, which is cooled by seawater. Seawater enters in and exits out. Seawater in a U-tube form, it enters in as a single pass and then double pass and then goes overboard after cooling the return steam. Once it is cooled, it comes to the tank called observation tank. Number 9 is called, this tank is called as observation tank, where you have a sight glass, where you can view what is in that, what is returning back here, and you can see a layer, in case if your settling tank has got a coil leak. Now this oil, it enters into your steam piping system, return piping system, and as it condenses, it comes down here and it will start floating up here. Now, the side glass is given for you to view and to know that there is somewhere some leak coming out. And once you know that the leak is here, then of course you have to go in for finding out where the leak is from. By isolating each and every tanks one by one, you can find out. Now, but then, of course, you have to scum it, you have to remove it out. So you have a drain line. Number 10 is a oil drain. This oil drain funnel, you can drain it, okay, to your oil bilge tank, you're draining it. Now, number 11, this tank has got a vent line. It's got a vent line. Of course, the tank, any tank leaving fluid passing through, you need to remove the air out from the top. It's just vented out here. Now, number 12, the casket tank. This tank is called as a casket tank. This tank, just follow this. This tank is called as a casket tank. This tank. Now, this casket tank, very carefully if you watch, what are the things in the casket tank? One, from the observation tank, the water climbs up this pipeline via this valve, it gets into the casket tank. It gets into the casket tank where it is segmented. It is segments, compartments like this is the first compartment, then it passes through the filter arrangement. This is the filter. 13, number 13 is this for a filter. It gets filtered and then comes to a next chamber where 14, the feed heater is here. Here you are heating up the water. Now, the condensate, what you receive from here, would be approximately at the temperature of maybe 40 to 50 degrees centigrade or so. Now this 40 to 50 degrees centigrade of water as it comes in, if you leave it through the feed pump, these two are the feed pumps. You see here, this item number 15 is the feed pump. Item number 16 is the feed tank. He's talking about this tank, feed tank, and then the makeup tank. He's talking about this tank where you make up the water in case of evaporation. You have to make up the water and maintain the boiler water level, and the pump should not lose suction. So you have to do a makeup business here. You have to do a little bit of makeup, topping up the tank and making sure that the casket tank is 3/4 full. Now, why do you need a heater? Here, see, feed heater. Very, very important. This feed heater is very important. It is provided to remove the oxygen contamination in the feed water. Now, why should we remove the oxygen from the feed water? Yes, we will see it in the next coming slide. Okay. Now, until now we have seen the circuit. Now, let's go to the core. Now, feed water treatment. Let's come here. Now, here. The boiler water treatment, the boiler water, the water supplied to the boiler is called as boiler water, or we call it as the feed water, which is stocked up and kept in the tank. Now, the need for control. Control what? Whether distilled or raw water is used for boiler makeup, chemical treatment is necessary to counteract harmful substances which are present. There are harmful substances in this water. You cannot take up water from anywhere and just supply it to the boiler like that. No, each and every water content present from various places have got some harmful substances. What are they? Now, particularly, the contaminants present in the raw water are inorganic sodium compounds of chlorides, sulfates, and carbonates, and the hardness, that is calcium and magnesium compounds of these small material are present in that water, in that raw water. Now, can we use this directly? We have to be careful. We have to treat them. How are we going to treat them? Let's see. Not only this, there are some gases also. Gases such as oxygen and carbon dioxide are present in the feed water. Distilled or raw water. It could be distilled water from your evaporator. It could have come out. But still, oxygen and carbon dioxide are present in that water. Now, is oxygen and carbon dioxide good where you can send it to the boiler? No, it is not good. Let's see what happens here. Now, marine evaporators do not remove all the salts and minerals from the seawater. Minute particles are carried over from the evaporator in the water vapor and are present in distillates. Now you see here, minute particles are carried over. Now where is the question of carry over in an evaporator? If you have studied in marine auxiliary missionary, we do study the freshwater generator. There, the heating system is from your jacket water cooling system. 85 degrees centigrade, the water enters inside, and you just give in a little bit of feed water. This is getting heated up, and then after heating, it goes out at 75 degrees centigrade. Now, this feed, what we have given, starts evaporating. Now, starts boiling and evaporating at a very low temperature, at around 50 degrees centigrade. It evaporates. How does that happen? Now, here it boils. How does that happen? It is because of vacuum. Your freshwater generator system is under vacuum inside. It is kept under vacuum. This water evaporates or boils up and evaporates at a very low temperature of 50 degrees centigrade. Now it evaporates. Now this evaporation, as it climbs up, there is of course a demister where the water particles should get filtered out and the salts also should get filtered out, just drop down. But sometimes there is a very good chance of carryover. A minute particles, sometimes it carries over and goes along with the condensate distillate. It condenses there is a condenser on top. It condenses, which is cooled by the seawater. It gets condensed, this distillate, vapors, condenses there and connects, it is getting connected to a feed pump, a small distillate pump, and that pump takes suction and pumps it to the, storage tank. A boiler water storage tank, or we have feed water tank and so on, and a fresh water tank, we just pump it and store it up. Of course, there is a salinometer which indicates how much is the salinity, chloride. It's 1 ppm or 2 ppm. The setting is kept at around 5 ppm. If it goes beyond that, it will give you an alarm. It will dump the water back again into this evaporator system. Okay, so that's what he's talking about. Minute particles are carried over from the evaporator in the water vapors. Now, this is also not good. Any leakages in the distiller, condensers, and any part of the feed system which is seawater cooled will add solids and further magnify the existing problems. Anyway, if you have any minute leak in the condenser which is used here for cooling the vapors, now then it will aggravate. It will aggravate. Now here, impurities in water, the continuation of it. All natural waters contain various types and amounts of impurities. These impurities cause boil problems, and as such, considerations must be given to the quality and treatment required for the water used for generating steam. Now when we are using this water for generating steam, then we have to pay extra caution. Yeah. For any type of treatment, sediment filtration, usually with cartridge filter, is the first step. First and the foremost, you just have a small, filter with, it's called a sediment filter, which removes the sediments from the water. Natural waters contain suspended matters, dissolved solids, and dissolved gases. It's what is called dissolved solids. It is got, and dissolved gases also it is got. Natural water. Now, water being a universal solvent dissolves minerals, rocks, and soil that comes in contact with air. Whatever, as this water passes down, whatever comes in contact with it, like it could be minerals, rocks, and solids, it will, absorb. It comes in contact with it, it will absorb. It dissolves gases from air and gases that are given off from organics in the soil. It picks up suspended matters from the earth. All this it picks up, this water. You receive shore water, these kinds of problems you will come to face. Additionally, it may also be contaminated with industrial waste and processed materials, like industrial waste, like your, the tannery industry, or you take textile industry and so on, any other industries where the wash water is left out. This could contaminate with this, natural water which is available, and when you receive it, this can also get carried, will be present in the water what you are receiving, and you take it on board. If you are receiving water from shore, this could happen. Dissolved minerals picked up by the water contain mainly of calcium carbonate, which is called as limestone. Then calcium sulfate, gypsum. Gypsum usually we use it for agriculture purpose, gypsum. Then magnesium carbonate, dolomite it is called. Then magnesium sulfate, Epsom salt. Silica, which is nothing but sand. Then sodium chloride, common salt. And hydrated sodium sulfate, galvanized salts, and smaller quantities of iron, magnesium, fluorides, aluminum, and other substances. My God, there's a hell of a lot of substances present in it, which we have to deal with, and make sure that the boiler doesn't get disturbed. Means boiler doesn't lead into boiler corrosions and so on. So we are going to deal how we're going to tackle all these, substances which are present in the water. Now, nitrates and phosphates found in the water are usually due to sewage contamination. Whenever you see the nitrate level too high and the phosphate level too high, then you are very sure that sewage has contaminated with this water what you are receiving. Water hardness. When we talk about water hardness, here it talks about calcium and magnesium minerals. Calcium and magnesium minerals. The amount of hardness in natural water can vary from a few ppm to about 500 ppm it can vary. Okay. Calcium and magnesium compounds are relatively insoluble in water and tend to precipitate out. They are insoluble and they tend to precipitate out. This causes scales and deposit problems. Such water must be treated to make it suitable for steam generation. See, here we see that calcium and magnesium, they are insoluble in water, and hence what happens when you treat it, when you treat the boiler with such a water, it forms scale and deposits, and you have to remove them out, you have to treat them out, okay, and take care of the steam generation system. Now, dissolved gases in water. What are the different gases that are present? We did say, oxygen and carbon dioxide and so on. Dissolved gases in the air is 21% oxygen, 78% nitrogen, 1% of other gases involving carbon dioxide. Now, water can contain up to 9 ppm oxygen. Water normally can contain up to 9 ppm of oxygen at room temperatures and atmospheric pressure. In the engine room, it is engine room temperature, yeah, and atmospheric pressure. In the hot well, up to 9 ppm is permitted. Now, as the temperature increases, the dissolved solubilities of oxygen decreases. See what it says? As the temperature increases, temperature of the feed water increases, the solubility of oxygen decreases, but water under pressure can hold higher amounts of dissolved oxygen. Now this is the reason, see here, solubilities of the oxygen decreases. This is the reason that in your hot well, in your casket tank, you raise the temperature, you raise the feed water temperature from 45 to 50 degrees centigrade, which was coming from the condenser, getting into the observation tank. From there it was coming to the casket tank. Via the filtration arrangement, it was passing through a chamber where the feed water is taking suction. There you have seen the heating coils were provided. You have to open steam to the heating coil and heat this feed water and get it to a range of 80 to 85 degrees centigrade, and at the same time the pump should not lose suction. Main thing, you should not just boil it out. By you taking this as a statement, solubility of oxygen decreases. Also very good news. So let's boil it out. No, you're not supposed to do it. You don't boil it out. Maintain the temperature between 75 to 78 degrees centigrade. You just maintain it, and you make sure that the feed pump doesn't lose suction. The feed pump should not lose suction. Gasification can take place in the suction side. Then the pump will lose suction, and then the boiler it will start reducing in level, boiler water level, and you'll have a low water level alarm. Low water level alarm, and then comes low water level alarm, and the burner system trips and the boiler will trip. Okay, so don't leave it to that extent. But remember, under pressure, the oxygen will again increase. If it is kept, water is kept under pressure, then the oxygen content will increase. Nitrogen being inert. Now let's come to oxygen we dealt with. Nitrogen. Now nitrogen being inert has little effect on water used in boilers. Now water can contain 10 ppm of carbon dioxide, sometimes much more than that due to decaying vegetations and organics in soil. Now hydrogen sulfate and methane may be dissolved in water, but this is rare. Air contains oxygen, then nitrogen and dissolved gases. Yeah. Okay. Now these gases can be troublesome when they are present in feed water. Okay. Now, other impurities in water. What are the other types of impurities in the water? Yes, I hope by now you have understood what exactly we are coming to. The quality of water is that we are talking in this third unit. How we are going to treat this? How are we going to tackle this situation? Tackle these kinds of minerals, solids and gases. How are we going to tackle it before or in the boiler system, so that the boiler corrosions should not take place. It should not disturb the steam circuits and so on. Natural waters contain various levels of solids, sands, turbidity, color, precipitated minerals, oils, industrial waste and other suspended solid particles. We have read enough time. Turbidity is due to very fine organic materials and microorganisms as well as suspended clay and silt. Now color is due to decaying vegetable matters. Now here so much of material, insolubles, impurity we have, and we are going to deal with that. Yes. Now, in a boiler, we have seen, before reading this I would like to explain, the blow-down system. As we were constructing designing and getting the boiler constructed, fabricated and put up one to one and welded and so on. we put the end plates and the circumferential substance and then the furnace area and the tubing and so on. We did, all that. We know that we fixed the scum blow down and the bottom blow down. This blow down system plays a major role. Any contaminants in the boiler, or chemicals like liquid coagulant and all these things, when we use in case of presence of oil and so on, suspended substances are found in the boiler. You have to scum blow down, and total dissolved solids are high in the boiler water. Then we have to do a bottom blow down and so on. Let's see what we can do on that. Now, boiler blow down is the removal of water from a boiler. Now, this purpose is to control boiler water parameters within prescribed limits to minimize scale, corrosion, carryover and other specific problems. To keep them under control, to keep all the parameters under control in this boiler water, the blow down system is going to help us. Now, blow down is also used to remove suspended solids present in the system. These solids are caused by feed water contamination, by internal chemical treatment precipitates, or by exceeding the solubility limits of otherwise soluble salts. Now here, the internal chemical treatment precipitates, where I said this is the one which keeps the oil under suspension, keeps the treats the water and keep them under suspension, and it is readily available for your blow down of the boiler. Okay, so now, yes, common impurities found in the water. Again, a continuation of it. Now let's talk about calcium carbonate. Now, calcium carbonate precipitates at the boiling point of water. It has a measurable solubility in water of approximately 19 ppm. 19 ppm, it is not measurable. You can measure it. Now, this solubility is sufficient to cause it to form scales. Now, that ppm is enough to form scales. So, you have to treat them and bring it down in ppm. Now, calcium sulfate. Calcium sulfate precipitates, forming a hard scale if the solubility at a given temperature is exceeded. For example, 104 degrees Fahrenheit, the solubility is 1551 ppm. Now watch this very carefully. I'm going to raise the temperature from 104, I'm raising it to 212 degrees Fahrenheit. Now what happens to the ppm? Solubility, it decreases. See? 1551 ppm to 1246 ppm, and then next, if I raise it to 428 degrees Fahrenheit, it could come down to 40 ppm. So it's good to raise the temperature here. It's good to raise the temperature here. Calcium sulfate has an inverse solubility because less solubles as the temperature increases, causing decomposition problems, depositions problems. This negative solubility characteristics make it more prone to crystallize where the heat is greatest, principally in the firebox where the highest heat concentration occurs. Now, firebox, we call it as the furnace area. The furnace area where the corrugations are, the temperature is very high. That's the area where it can land up with the calcium sulfate, precipitations. Now, magnesium sulfate, MgSO4. Magnesium sulfate is one of the most solubles of salts, having a solubility of 20% in cold water. Watch this. It's got a solubility of 20% in cold water and 42% in boiling water. Cold water is 20%, but in boiling water it is 42%. It exceeds only in water. It exits, only in water of low pH value. Yes, I think with this. We have gone through, solids present in the solids and gases and impurities present in the feed water system. And thank you very much for being very attentive. I hope I have not bored you all. And now I would like to put forth some questions. If you have some questions, you can ask me and I can answer you. Or if you're, you can just note it down and you can just email it to me or send a WhatsApp message to me and I can answer to you as convenient, as time permits. And of course, my next professor is waiting there, so I have to hand over the class. And goodbye to you. Meet you tomorrow. Thank you. Bye-bye.